So if we distribute here, start by distributing that negative 6. Here I get negative 12x, negative 6 times 1, minus 6. Distribute the negative 3, negative 3x, and negative 3 to negative 4. That becomes a positive 12, and I would say be careful on that. That's where a lot of mistakes get made because of the negative times the negative. Then you want to combine the like terms on the left, so negative 12 and negative 3 is negative 15x, and then negative 6 and positive 12 is positive 6. And then it doesn't matter what order you do these next two steps, but when you add the 15x, they cancel out, and what's left is 6 equals 1. This is not a true statement, so this would be a no solution scenario. On web assign, it's D, N, E. Okay, if it's open-ended, I would take any of those, like no solution, the 0 with a strike through, D, N, E, that's fine. But on web assign, it wants that D, N, E. Questions on that one? Okay, then 19 and the last parentheses missing from there, but you have two choices. This time it's not awful to distribute that 1/2 because everything inside the parentheses is even. So if I just distributed the 1/2 in there, I would have gotten 3x plus 7, and that's totally fine. Since we worked with the fractions last week by multiplying by the least common denominator, you could have also done that. But if I do that, you have to be careful what you're multiplying that by. So we know it's 2 because it's the only denominator. So that left side's going to get the 2. This x gets a 2. This 1 gets a 2. And this parentheses also gets a 2. Each term separated by a plus or minus, with the exception of what's inside the parentheses, is going to get multiplied by that 2. So on the left, the 1/2 and the 2 cancel, and you just get 6x plus 14 equals, this would be 2x plus 2, and then 2 times 2 would be 4 times x plus 3. I would distribute the 4 inside here. I get 4x plus 12. And then I want to combine my like terms on the left-hand side. The right-hand side, sorry. 2x plus 4x, which is 6x. And then positive 2 and positive 12, positive 14. If you catch it there, you can stop. This is all real numbers. If you keep going, you're going to eliminate the x's, and you get 14 equals 14, which is a true statement. Or if you would move the 14, you get 0 equals 0, which is still a true statement. You distributed, it's fine, you distribute the 1/2. Yeah, that's fine. It wasn't bad to distribute the 1/2 this time because they were both even. Yeah. But what we're about to do today is more of the fractions, so I just want to review that. Questions? All right, so chapter 1, section 2b is solving rational equations. Rational equations means these are fractional equations, okay? The difference between what we were doing before and what we're doing today is that before they were all just numeric in the denominator, and now they're going to look like they did when we did rational expressions, where you've got variables and expressions in the denominators. The same rule applies to start. You want to eliminate the fractions by multiplying by the least common denominator, and then what's important now that we haven't had to worry about yet is we have to check for extraneous roots. We talked about, So an extraneous root is one in which you would get that as an answer if you were just solving for x, but when I plug it back in, it would give me an undefined answer because the denominator would be 0, and when we divide by 0, it's undefined. So you're going to first look at your fractions. You're going to say, what would make these fractions undefined? And then you'll check to make sure that at the end you don't use an answer like that. If you do get an answer that you literally just cross it out, and it would be called an extraneous root. So that extraneous root would only happen if there's a variable in the denominator. So we only got to worry about it with number 4. Up until that point, they're all just numeric values in the denominators. So I'm going to look at 1. I'm going to figure out the least common denominator, which would be what? 12. And I'm going to multiply every term by that 12. So on the left-hand side, the 3 goes into 12 4 times. I get 4 times x. The plus comes from the middle. The 4 goes into 12 3 times. I get 3 times 3x, which is 9x, equals 12 times 2, which is 24. Combine your like terms, so 13x equals 24, and then divide both sides by that 13. And you can leave it as 24 over 13. You could convert it into a mixed number. It doesn't matter. As long as that fraction is simplified, you could leave it either way. I would say don't waste the time putting it into mixed number if you don't have to. 2, my least common denominator is now what? 15. I'm going to multiply it here. I'm going to multiply it here. I'm going to multiply it here. 5 goes into 15 3 times. 3 times 2x is 6x plus 5 times 15 is 75x. And 3 goes into 15 5 times. 4 times 5 is 20. So I get 81x equals 20. Divide both sides by 81. And x equals 20 over 81. Questions on that one? All right, then we go to 3. What's my least common denominator? 10. Good. 10 here, 10 here, 10 with the 3, and 10 with the 3x over 10. 5 goes into 10 2 times, 2x. The minus comes from the middle. 2 goes into 10 5x. 3 times 10 is 30, and the 10s cancel from here, and it's 3x. Combine your like terms on the left, so it's negative 3x equals 30 plus 3x. I would subtract the 3x. Negative 6x equals 30. Divide both sides by negative 6, and x equals negative 5. Still good? Yeah? Okay, so now I go to 4, and what's different with 4 is that there's a variable in the denominator. Up to this point, all the denominators were numeric values, but this one has a variable in it. So before I even start solving, I want to remind myself at the end that there is a value that x cannot equal. So I would look at my denominator, and I would say this cannot equal 0. So at the end, I'm going to remind myself x cannot equal 0. If there was another denominator that's different, I would set each of them not equal to 0 and figure out whatever the values are that would make it 0, because then it makes the whole thing undefined. So if I get to the end and my answer is x equals 0, then I literally eliminate that option, and I would say there's no solution. If there's 2 answers and one of them doesn't work but one does, you keep the one that does. But you cannot use 0 because it would make it undefined. All right, so now I'm going to multiply by my least common denominator, which is what? X. So this gets the x, and this gets the x, and this gets the x, and this gets the x. These x's cancel, so I have 15, the minus from in front of the 4. 4 times x or 4x equals these x's cancel. I get 6 plus 3 times x, which is 3x. Now I can subtract the 6. 9 minus 4x equals 3x. Add the 4x. 9 equals 7x. Divide both sides by 7. And x equals 9/7. That is not 0, so that is my answer. I get to keep it as an answer. All right, then you get something like 5. So there's actually 2 ways to do 5. One is, this is a proportion, right? You've got one fraction on either side of the equal sign. So you can cross multiply, or you can multiply by the least common denominator. Before I do either of those, because there's a variable in the denominator, I'm going to check for my extraneous root. So the 2 doesn't matter, but the 5x plus 6 cannot equal 0. And then I would solve this. I'd get 5x cannot equal negative 6, and x cannot equal negative 6/5. So if at the end I have negative 6/5 as an answer, I cannot keep it.
So why do we write that?
Because if I get that answer at the end, I cancel it out. It would be no solution. It's called an extraneous root. So there are going to be times when you get the answer that would actually make it undefined, and you can't keep it. So you cancel it out.
How do you tell if it can't equal something?
If there's a variable in the denominator, you set it not equal to 0. Whatever's in that denominator, you set not equal, like what we just did. We set it not equal to 0, and when we solve for x, and that's what you cannot use.
Wait, so if it can't equal 0, why? Wait, so it also can't equal 3 or 6. I'm sorry, why did you write 5x?
I solved the bottom by setting it not equal to 0. So it's not that it's not that x can't equal 0, it's that my denominator can't equal 0. So I have to set my denominator not equal to 0 and solve, and that's the value in which it cannot be.
Okay.
All right, so I could, like I said, I could multiply, and in here, my least common denominator would be 2 times 5x plus 6, because it's the combination of those two. And I can cancel the 5x plus 6 into here, and I get 2 times 10x plus 3. And on the right-hand side, I can cancel out the 2's, and I get 1 times 5x plus 6, or 5x plus 6. And then I can distribute here 20x plus 6 equals 5x plus 6. Subtract the 5x. Subtract the 6. Divide by 15. What's 0 divided by 15? 0. 0's in the top, it's 0. So now because that does not equal negative 6/5, I get to keep that answer. If my answer had been negative 6/5, I cannot keep it. There would be no solution.
How did you know that it couldn't be negative 6?
You set the denominator not equal to 0. So whatever denominator has a variable in it, you set it not equal to 0 and solve it. And that's what x cannot be. We're going to keep doing it every single time. Set the denominator not equal to 0. Anytime there's a variable. Yep.
Oh, what does it?
All right, go to 6. Do I have a variable in the denominator? Yes, and they're two different expressions this time. I have to set them both not equal to 0. So then x cannot equal 0. That's one restriction. And then x minus 5 cannot equal 0, so x can also not equal 5. So my restriction is that it can't equal 0 and it can't equal 5. So now after I solve it, if I get either one of those answers, I can't keep them. So step 1 is figure out what it can't be by setting your denominator not equal to 0. Then go back and solve this. So I have two options. Oh, and I said it before, but we didn't work it out on the last one. I could have also just cross multiplied here. I could have done 2 times 10x plus 3, and then 1 times 5x plus 6, and I would have gotten the same answer. So if there's only one fraction on either side of the equal sign, you could have also just cross multiplied, okay? Given that, if you look at 6, there are 2 on one side of the equal sign, but the other side is 0. So I can actually move this to the other side by making it 1 over x equals, and it would be negative 2 over x minus 5. Like if I subtracted it and moved it to the other side. And then you can cross multiply again. So if you can move them so that there's 1 on either side, you can also do that and you can cross multiply. I'm going to keep it how it was in the beginning, but that is an option. Yeah.
The only 2 are these 2.
That it can't be. Yep.
Why wouldn't it be x minus 5?
X minus 5 cannot equal 0. So when you solve for x, x cannot equal positive 5. Negative 5 is fine, right? This would be negative 5. This would be negative 5 minus 5, which is negative 10. Those can be in my denominator. It's 0 that cannot. Okay, now I know what it can't equal, but now I still have to actually solve it. So what's the least common denominator of this equation? X times x minus 5. So that one gets that. X times x minus 5. That one gets that. X times x minus 5. And then I cancel them out. So the x goes into the x, and I get 1 times x minus 5, which is x minus 5. The plus that comes from the middle. The next one, the x minus 5's cancel, and I get 2 times x, 2x. Equals on the other side of the equal sign, 0 times this is just 0. Combine my like terms on the left. I get 3x minus 5 equals 0. Add the 5. 3x equals 5. Divide by 3. And x equals 5/3. Because that's neither of the things we said it cannot be, that is my answer. All right, go to 7. So I'm going to start by doing what? Before you do that, though. Yes, you're going to do that, but Lauren. So say this cannot equal 0 and this cannot equal 0, right? So if you wanted to rewrite it off to the side so you don't confuse yourself, you totally can. Neither of those can equal 0. So then 2x cannot equal -1 and x cannot equal -1/2. And then add the 1, 2x cannot equal 1, so x cannot equal +1/2. So those are the two things x cannot equal. Those are restrictions on what you can plug in for x. And now we want to go back and find the least common denominator and solve this. What's my least common denominator? Are 2x plus 1 and 2x minus 1 different terms? Yeah, so they both, 2x plus 1, 2x minus 1, are my least common denominator. So from the first one, the 2x plus 1's cancel. And I get 7 times 2x minus 1. So I'm going to write it with the parentheses so I remember to go back and distribute that. Then the minus that comes from in between. The 2x minus 1's cancel this time. And I get x times, or 8x, sorry, times 2x plus 1. And on the other side of the equal sign, nothing cancels out. So it's -4 times 2x plus 1 times 2x minus 1. And I'm going to have to multiply that out. With me so far? All right, so I'm going to distribute the 7. This 7 gets distributed to both. This is 14x minus 7. I'm going to distribute a -8x. So this is -16x squared minus 8x. And then on the right-hand side, you have two choices. One is distribute the 4 into one of them and then take what you get from that and FOIL it out with the second one. Or I would say, because this is a special product, I would start with those two first. So they're the same, but the sign in the middle is the opposite sign, which means these are going to result in the difference of two squares. So the -4 is going to stay. I square 2x and I get 4x squared. I square the 1, I get 1, and I put a minus between them. So that's your shortcut when you're multiplying those two terms. Same expression, opposite signs. Or you could have FOILed it out. The middle terms would have canceled out. So on the left, I still have 14x. Actually, let me combine my like terms in this step. So 14x minus 8x is 6x minus 7 minus 16x squared equals, distribute this in, -16x squared plus 4. I want to add the 16x squared to both sides, and it cancels it out. I get 6x minus 7 equals 14, or equals 4, sorry. Add the 7, 6x equals 11, divide by 6, and x equals 11/6. Again, check to make sure it's not one of the things we said x can't equal, and it's not. So that's my answer. All right, so what's new with 8 that we haven't had to do yet? There are 3 fractions, and what's true about that last one? It's the difference of 2 squares, I can factor it. So before I find my least common denominator, before I figure out what x can't equal, I'm going to factor it. So this becomes x plus 2 and x minus 2. Then I want to figure out what x can equal. So x minus 2 cannot equal 0. X plus 2 can equal 0. And then I have the same things, but they are repeated the last time, which means I don't need them again. So I get x cannot equal 2 and x cannot equal -2. What's my least common denominator?
X plus 2 times x minus 2.
Good. So each fraction's going to get it. X plus 2, x minus 2, x plus 2, x minus 2, and x plus 2, x minus 2. Then I cancel my denominators in. So x minus 2's cancel. I get 1 times x plus 2, which is x plus 2. X plus 2 cancels from the second one. I get 3 times x minus 2. And x plus 2 and x minus 2 cancel from the last one. So I have just minus 6x. I'm going to distribute the 3. Combine my like terms, x plus 2, negative 3x minus 6. Add the 3x. Subtract the 2. Divide by 4. And I get x equals negative 2. But what? We said x cannot equal negative 2, right? So even though we got that as an answer, we can't keep it. We literally say, nope, this one is going to have no solution. If I had gotten 2 answers, then there would be 2 answers and I could cancel out one of them if that's possible, okay, and keep the other one. But if that's the only answer you've got and you can't keep it, then it's literally no solution.
How do you get 2 answers?
It would be if it's something like x squared, which we're going to get to in a little bit. We're going to talk about solving by factoring, which is tomorrow's stuff. So you'll see that tomorrow. Questions? So that is like if it's multiple choice, answer A is going to be negative 2, and you're going to circle it and you're going to feel confident because you forgot about the restriction, and then you lose all the points there. So you got to be really, really careful with these.
Can you go back to 5?
Mm-hmm. All right, so in 9, first you want to check to see, can anything be factored? Cannot. Then I want to go through and set all the different denominators not equal to 0. So x minus 4 cannot equal 0, and x minus 4 would repeat again, which means I only need it once. X cannot equal 4, so there's my restriction before I even start. My least common denominator is what? X minus 4, so I'm going to multiply there, there, and there. From the first one, the denominators cancel into the least common denominator. So I get just 3x. Then 5 times x minus 4, that 5 is going to get distributed to both. And then the x minus 4's cancel again, so it's plus 12. So 3x equals, distribute here, 5x minus 20 plus 12. 3x would equal, combine my like terms here, 5x and then minus 20 plus 12 is minus 8. Subtract the 5x. Negative 2x equals negative 8. Divide both sides by negative 2. And x is 4. Can I keep it? No, this is no solution. So with these questions, like every single one of them can be checked. Some are easier than others to plug back in. If you go to plug this back in, you're going to get a 0 in the denominator. And then when you divide by 0, you know it's undefined. But if you just remember that restriction at the beginning, it saves you that extra couple of steps. All right, go to 10. This time, okay, it's already factored. The bottom left is already factored, but I'm going to take each of those separate terms and set them not equal to 0. So x minus 1 cannot equal 0, and x plus 3 cannot equal 0, which means x cannot equal 1, and x cannot equal negative 3. Then least common denominator is x minus 1, x plus 3. X minus 1, x plus 3. And x minus 1, x plus 3. From the first fraction, both cancel. It's just 12. The second one, x minus 1, cancels. So it's 3 times x plus 3. And the last one, the x plus 3's cancel. So it's 2 times x minus 1 with a plus in between. So plus 2 times x minus 1. Distribute the 3. Distribute the 2. 12 would equal 5x plus 7. Subtract the 7. Oh, 5, sorry. 5 equals 5x. Divide by 5, and x equals 1. Can I keep it? Nope. So again, no solution. All right, you do 11 and 12. Make sure you factor them first. So for 11, the second or the last denominator would get factored. This would be x plus 3 and then x minus 2, which means x minus 2 cannot equal 0 and x plus 3 cannot equal 0, which means x can't equal 2 or negative 3. And then the least common denominator is x minus 2, x plus 3. X minus 2, x plus 3, x minus 2, x plus 3. The x minus 2's cancel here. I get 1 times x plus 3, which is x plus 3. The plus from in between. X plus 3's cancel, and I get 3 times x minus 2. And then both x plus 3 and x minus 2 cancel, so it's just 4 on the other side of the equal sign. I'm going to distribute the 3, combine my like terms, add that 3, divide by 4. And x is 7/4, which was not one of my restrictions, so that's my answer. Questions on that one? Raise your hand if you got it right. Okay, good. All right, the last one, 12's got to get factored again. The last denominator, you can take out an x. So then x cannot equal 0, and x plus 3 cannot equal 0, which means x cannot equal negative 3. So my least common denominator is x, and then x plus 3, x and x plus 3, x and x plus 3. From the first one, the x's cancel, and I get 6 times x plus 3. There's a minus this time, so minus the x plus 3's cancel. It's 2 times x equals the x and the x plus 3 cancel, so it's just 3 times x plus 5. Then I'm going to distribute, so 6x plus 18 minus 2x equals 3x plus 15. 6x minus 2x is 4x plus 18 equals 3x plus 15. Subtract the 3x. X plus 18 equals 15. Subtract the 18. And x equals negative 3. But we said x cannot equal negative 3, so we cancel this out, and it's no solution. And remember, on WebAssign, that would be a DNE, right? No solutions, DNE on WebAssign for does not exist. Questions? Okay, so we're going to go one more section and then pause for a quiz. So tomorrow's lesson is 1.4a. We're going to do that, and then we're going to pause for a quiz, which will be Thursday of this week. And then we go 2 more sections and then test next week, and that's the last one of the quarter.